Good morning, everyone. Am I audible? Please let me know. Am I audible? Hello. Good morning, everyone. Assis, Subham, Vishal.
Yes, sir.
Okay, so that means I am audible, right? Okay. Okay, so as you are already aware, so we have already once again started in the online class due to case of this COVID. Okay. So now let's wait for 1 or 2 more minutes for others to join. Or in the meantime, I'll be taking any question that you might have from the previous module or maybe from the this particular module from after the last class. So after the last class, have you understood the things?
Hello,
Yes.
sir. I'm present, sir.
Hello.
Sir, I'm present, sir.
Shubham is present. Yes, I know you're present, but you have not responded. Okay, no worries. So okay, so do you have any questions, Shubham? Seems no. So shall we start or we shall wait for some others to join? Okay, as none of you are responding, so I'm assuming that I can move ahead. Okay, so in the last class we are discussing about the third module, which is basically in that we have discussed about the chemical machining process. Okay, in short, CHM. Okay, so there we have discussed that this chemical machining is nothing but a kind of controlled chemical dissolution of the workpiece material, which will come in contact with a particular strong reagent. Okay, so that strong reagent might be like a strong alkali or strong acid depending on the workpiece and the whatever is the reagent material that is available to you for doing that particular control kind of chemical dissolution. So there we have discussed that basically to prevent the areas, certain areas from any kind of dissolution where we don't want any machining to happen. So we'll be using some mask there. Okay. And by using the particular mask, okay, in the proper whatever is the desired shape and all, in that case, by using the proper mask of proper material, so we can protect the areas from which we don't want any material to be removed. Okay, and there we have already discussed that this particular chemical machining process, it's a kind of very good for producing kind of pockets or contours, or even we can do even polishing kind of thing also. Okay, and it's a kind of selective kind of etching process that we call. So right now, whatever material is being removed, that is nothing but the kind of etching process. Okay, so etching happen. That's why, and as the material will be removed from the wherever is the desired location by means of applying the particular type of mask, so it's a kind of selective etching process. Okay, and depending on what there may be kind of various varieties of this kind of chemical process, like we have discussed that. The two major varieties is like chemical planking, chemical milling. These are two of the main kind of chemical machining process. But apart from that, we can even have chemical engraving, chemical polishing, etc. But whatever be the kind of process, but there are certain basic steps which are available, which will be common to any kind of process, any kind of chemical process. So basically, we go for like initially preparing and the cleaning of the workpiece surface. Okay, and then really we use the mask, we produce the particular mask. Okay, and a strippable kind of mask that is there. Okay, so there may be cut and peel kind of process or other kind of process that is available for this doing masking. So after that, like application of the mask, doing the etching, in proper whatever is the solution that you have taken, then proper rinsing of this particular workpiece and post processing, etc. These are some of the basic steps which are available in any kind of chemical process. Okay, and we know that during this kind of chemical machining process, so the depth of etch, that means whatever is the depth of cut. Right now, we can also call it as like depth of etch. Okay, because it's a kind of selective etching process. So this is basically controlled by the time of immersion. That means for how long you have kept that particular workpiece under the whatever is the acid or basic solution. Okay, that whatever is the reagent that is. Okay. Now later on we have also discussed about the whole process setup. So there we have seen that basically we'll be having this particular chemical reagent, as you can see in this particular figure. So to and the workpiece will be there. Workpiece has to be immersed in the whatever is the chemical reagent you select depending on the workpiece material, and it is generally hang or kept within kept in immersed position by a kind of hanger, and depending on where we don't require the material to be removed, we use the mask, proper mask. And in the exposed area, exposed to what, that is the exposed the areas which are not masked, those are exposed areas, and these exposed areas are exposed to the chemical reaction, and now from there chemical dissolution happens and material is being removed there. So there we have seen that there is a kind of undercutting that is always associated with any kind of chemical process. So what is this undercutting? As you can see in this particular figure, so undercutting is like, see, our right now here, this is suppose this black portion is the mask that you are using, and this portion where there is no black covering is there, that is unmasked portion, or it is nothing but the exposed portion. Now when I immerse this particular whatever is the workpiece material that we have already utilized, suppose depending on whatever is the way we want to have the edge, we have selected the particular mask material and we have utilized it. Okay, let's consider this is now covered. Okay, this is being now masked, and this particular portion is now being exposed. Okay, so now when I immerse it within that particular whatever is the chemical reagent that you have selected, so what will happen? So the chemical will come in contact with this particular exposed portion, and here the chemical reaction will occur and chemical dissolution will happen on that particular, etching will happen on that particular metal. But now our expected outcome was what? So we expected that actually in this particular portion there should not be any machining, that's why we have masked it. And this portion, at this particular localized portion, we wanted that there should be certain machining that should happen. Okay, material should remove from this particular portion, and once again from this particular back end portion there should not be any material removal from here. Okay, so now when we have immersed it, initially what will happen, this particular portion is prone to whatever is the chemical etching. Now let's consider this particular layer has been removed. Okay, now after that what will happen, in that side wall also will get exposed, right? So once, if we consider up to a certain depth already, suppose material has been removed, okay, chemical dissolution has already happened. So now what will happen, in this particular side wall also is exposed now to the chemical. Okay, and that's actually for the remaining of the time, actually whenever this portion also is being getting eroded, okay, it's and in that particular portion, in that particular time, the side wall also is exposed to whatever is the chemical region that is there, and once again chemical dissolution will happen from the side wall also. And thus, even though we expected that there is a sharp cutting or sharp material removal should happen like this, our expected outcome was somewhat like that. But now we know that now somewhat, just like in this particular lower figure, somewhat up to this much also material will be removed. That means there will be certain undercut which will be always associated with this kind of chemical process. And this particular, along this side, okay, along the depth side, whatever is the etching, whatever is the material removal that has taken place, that is nothing but the depth of it. And now there is a, as we have already discussed, there is a one factor known as the H factor, which is nothing but the ratio of the undercut by depth of cut, and that is very important. It gives you actually uh, in a particular process, particular chemical process setup, how much depth of cut you can expect in a single go with a proper, within the proper tolerance limit. Because say if we keep on, as we already know, the machining can be basically, if we go to the last portion. Okay, so now, so see, during say Chm, that is chemical machine, depth of H is controlled by the time of immersion. So now if you keep it for more time, so ultimately this side also will get exposed. Okay, the chemical will attack here also, and this undercutting you will get. So this portion is nothing but undercut. Okay, understood. And this is the depth of. Now you have to maintain a particular ratio Okay, that means how much undercut you can allow within how much depth of cut. Okay, so that's why this factor known as the edge factor, it is now very important. It is nothing but the undercut by depth of cut. Okay, these things already we have discussed. So if you have any question after the last class up to this particular portion, you can ask me, or if you have understood, you can let me know. Have you understood, Vishal? Subham, please let me know. Okay, okay, thank you, Tapas. Okay, so now here in this particular figure, I am showing that actually, even though we are saying that in this chemical measuring process, so directly wherever is the exposed area, that is the surface to be measured. Okay, so that is there, and directly in this particular case, this is one case, and this case we are showing how the same measuring can be used to get step etching also by doing the positioning in proper second. So now it's possible to directly suppose to this kind of either shallow kind of machining or deep machining, or ultimately we can say total, you can say cutting or separation of the two workpiece. So that is also possible, as well as we can give even some step by step or step etching also can be done. That means on the same workpiece we can have different contours. Okay, so now in the first case what is basically happening, it's the simplest one. So now here, this is the coated surface. That is, we are using what? We are using the mask. Okay, so mask is nothing but the coated surface, and here also there is the mask. And what is here? This is the exposed portion, right? And now exposed portion is nothing but it is the surface where we want machining to happen. Okay, what will happen? As you can see, so chemical will come in contact from all the sides. Okay, if I immerse it within, suppose whatever is the liquid reagent, chemical reagent. Okay, now as I have immersed it within that particular chemical bath, what will happen? So the area, the surfaces which are not coated, which are not masked, those are exposed, and from all the side it is exposed, and all from all the time at a time, for on the sides at a time, the chemical will attack the surfaces. Okay, and thus what will happen? This particular whatever is the etching. Okay, so that is also controlled by the time of immersion, that also we already know. Okay, so depending on how long you have kept it under immersion in that chemical bath, so actually chemical will come and this chemical dissolution will happen. So within that particular time, even though mask was here, so as the lateral surfaces are also being exposed, so from those areas also we'll be having material removal, and undercutting will be there. And if you keep it for a certain long amount of time, so once again the depth of cut will be more from both of the sides, from all the sides. Okay, the chemical will attack on the workpiece, and after a certain amount of time, this portion, okay, it will definitely keep on machining or like that. Okay, and after that even it is possible to separate these two pieces also. Okay, now they are separated. Okay, that is one possibility. They separate. Okay, now another possibility right now here you can see there is actually no contour is being given, no step, etc. But this particular chemical machining can also be properly used to get some kind of step kind of etching also. Step etching means what? Suppose this kind of contour you can expect on the workpiece, on the product ultimately. Okay, that is the workpiece after the machining is over, that is nothing but the product after the process is over. Okay, so now what you can do by properly utilizing mask, suppose this layer we are using mask, this is the initial workpiece. So what will happen? After a certain amount of time it will get exposed, and suppose this much depth of cut we can expect. Okay, let's consider this to be depth 1. Okay, now what will happen, we can take it out, and once again we can depending on how much you want to, where you want to have the step and all. Okay, so we can peel this portion of that particular mask now, and now this portion also is exposed. Okay, and now what will happen, once again we will immerse it within the whatever is the chemical, but now along with this previously exposed surface, now this is the new exposed surface, right? So now what will happen, the chemical will come and attack here also, chemical will come attack here also, on both the side. Okay, and as this is the similar kind of workpiece material, so from and it will be immersed within the chemical bath. So lower side is, we can say, here throughout the surface we have the mask. we have the coating here. So this surface is not exposed. That means material will not get removed from here. No chemical dissolution will happen here. Okay. But now in the second step, this portion, this face is also now exposed. Okay. Now what we expect now, that means along with this previously exposed area, so here also there will be chemical attack and exposure will be there. So now you can see after next step in the last step. Okay, let's consider the first initial step, second step, taking out the material workpiece. Once again, we are peeling this particular portion of this particular mask, and now this is now you exposed area. Now after the fourth step is over, what will happen? You can expect some step-like fashion. Material will be removed from here also once again. Okay, and from this portion also, now newly exposed area also material will be removed. Okay, now what is the total depth of cut that you have then? It is nothing but, let's consider this to be second depth of cut 2. Okay, then what will happen? Initially whatever is the depth of cut it is there, so the total depth of cut will be in this particular portion. Okay, 1 plus depth of cut 1 plus depth of cut 2. Okay, so this is how you can even get step by step kind of etching. Now if you once again you require suppose some if you want to have this kind of fashion. Okay, now once again what you can do, if this is the final product shape that you need, now you can take it out once again, and this portion of the mask you can remove, right? So you can remove this portion of the mask, and then this portion of the surface will be exposed, and chemical will come and come in contact here. Okay, chemical dissolution will happen, and material will be repeated. But mind you, so this portion, these faces are actually, these edges are not that much sharp. Getting very sharp edge is somewhat difficult, because at the time when actually we're increasing the depth of cut, the surface, the lateral surfaces gets exposed, and from the lateral surface also some material is being removed. Okay, so I hope I have understood up to this much. Let me know. Have you understood or not? Okay, thank you. Now, by this time, I believe all of you have already understood that in kind of chemical machining. Okay, so the mask or the masking material, okay, it plays a very important role. Okay, that means we should be able to select the proper masking for the proper utilization purpose. Okay, and now the selection of proper masking for a particular application, now it is actually dependent on certain factors. Mainly there are 6 different factors which are generally evaluated, okay, with respect to the job, and whatever is the with respect to the work material and the job. Okay, and thus we go for selection of the proper masking for a particular application. Now, what are some of the masking selection factors and its different consideration that we'll see? Okay. Now, mask selection we are talking about, and factor was chemical resistance. Okay. Now, what is the consideration? So now, in case of chemical resistance, the thicker the masking. Okay, that means, see, if you're talking about a particular mask. Okay, mask is that particular material which will be not eroded during that process of machining. Okay, even though it is, this mask is also exposed to the chemical, but the chemical will not be able to erode away the mask. Okay, but if you keep it for a very long time, there will be surface degradation of that particular mask also. Okay, so you have to you have to judicially use that particular masking. Okay, and similarly, what is the thickness of the masking? Okay, or the mask, that is also important, because see, if the top layer of the mask gets eroded due to the very rectification of any kind of whatever be the type of reagent that you have used, still will have this particular layer which will save the surface which is just below it. Okay, but if the thickness of the mass material itself is thin, now what may happen? If you keep it within immersed position, okay, in the immersed condition for a longer amount of time, so this mass can itself, there is a chance that it itself will get eroded, and now this layer of the workpiece which is just below the mask also may get exposed, and if it gets exposed, the chemical will penetrate here, and chemical will do its work means it will erode it. Okay, so now the thicker the masking, the longer the exposure time before the masking is destroyed. Okay, that means what, if you want to have a kind of deep etching, okay, deep depth of cut, it's this particular depth. Okay, now in that particular case, by utilizing a thicker mask, comparatively deeper comparatively deeper depth of cut you can get. Okay. Similarly, the part configuration, that is what is the geometry of the part, that also plays a very important role, because there will be some mask ends which are only applicable to flat parts. Okay, that means suppose if you have flat surfaces and all, you'll be able to sub cut and peel kind of mask. Okay, which will just adhere to the surface. You can just coat it there. Okay, so that kind of that kind of coating can be applied to flat surfaces only. Similarly, quantity of parts also is a kind of factor for mark selection. Okay, the why what should happen to the particular mask? Suppose if we have a large number of quantity of the parts that has to be produced. Now, in that particular process, we know that for each and every case, we have to produce that particular mask. Okay, so now whenever the quantity of part is kind of the main factor, okay, then for higher production quantity, the masking process should be less labor intensive. Because if we have to devote more time, more amount of labor in making the mask itself, then actually the whole process will be not that much efficient. Okay, so in that case, we have to judicially select that particular mask, which will be less labor intensive. Similarly, cost also plays a very in just like in any case, cost also plays a very important factor. Okay, so generally the materials are generally somewhat costlier. Okay, and the better is the quality of the mask, which ultimately needs to be removed from the workpiece. Okay, generally depending on whatever is the kind of glue or adhesive property that is there, better is the property, actually higher is the price of it. So you have to judicially select the cost also. Okay, and definitely one of the another important factor is ease of removal of that particular mask after the process is over. Because see, the mask we use on that particular surface to just to we can say protect that particular area of the surface from where we don't want any material to be removed. Okay, now after the process is over, suppose it has done its job, so there is no need of there is no requirement of that particular mask on that particular final product, so we should be able to we have to remove it. And now ease of removal of that particular mask also plays a very important. If the situation is such that you have to destroy, like suppose hammering or like that, any kind of process, you have to just destroy that particular whatever is the layer of the mask that you have produced. Okay, then it is not an ideal kind of masking. Yes or no? Because that during that particular chipping or hammering action, the area it's which is beneath that particular mask itself will it may get distorted. Okay, distorted. Okay, so that is another factor. And what is the resolution that you require? That is one of the very primary consideration of any mask. Okay, you will see later on in the photochemical machining, etc. The very high resolution masking technique it is required, because ultimately the finer the kind of, we can say, the closer the tolerance that you require. Okay, the finer should be the resolution. Okay, and the depending on how what is the quality of the mask and how properly you have applied the mask, etc. Actually, gives you the whatever is the it dependent on the that is one of the, you can say, key factor which actually talks about the resolution of the workpiece, resolution that will be achieved on the workpiece. Okay, so these are some of the characteristics, or can say important factors that needs to be considered. Okay. Let me know whether you have understood or not. Tapas, have you understood? Shubham?
Yes, sir.
Okay.
Yes,
Okay.
sir.
So, okay, thank you. So now by this time we know that, so that ethane, that is nothing but the chemical that we are going to use. Okay, that's ethane. Okay. So basically, what does it do? The ethane, it is used to dissolve a metal. That is, metal means the work material that we are talking about, by turning it into a metallic salt. Okay, and there are a variety of different ethane that is available for which is compatible with different metals and all. Okay, so now there is a list that I have provided along with the like what is the metal, if we just like suppose aluminum, if you want to mention aluminum, so what is the preferred ethane? So ferric chloride is the preferred ethane. Okay, and what is the its rate, that is the how much metal is being removed. Okay, per unit time, so in millimeter per minute that is given. Okay, so its rate is kind of in the range of 0.025 millimeter per minute. Okay, and its factor undercut by depth of cut, that you already know, it is 1.7:1. So like that, like if we have to like other metal that you want to mention, so this cert is being provided, which will be useful, which will be helpful for proper selection of the its. Okay. Similarly, its selection also plays a vital role. So that also depends on certain factors like what is the surface finish that you want to achieve on the final product. Based on that, also you have to select the its. Similarly, the removal rate, that is how at what rate you want to do the machining. Okay, metal type, definitely, as you can see from that particular list. Okay, depending, you cannot have any kind of like it's for any kind of metal. So there is a optimum piece and it's in combination that is there. Okay, so all the it's an will not work in a preferred way in on all type of metal. Okay, similarly the costs of it, its depth, etc., are some of the key parameters which actually governs the use of this itself. Okay, so some advantages and disadvantages of this process. It's like, as you can see, like many workpieces can be etched simultaneously. Also, all the surfaces which are exposed, they are simultaneously exposed, so simultaneously machining will kick on. So as it's a kind of chemical process only, you have seen that there is no tool, etc., involved. Ultimately, no tool force. It's a kind of chemical process. So there is no distortion of the metal. So that means very thin and delicate metal can be worked up. Okay, and as you can see, it's like the workpiece metal you should have the masking, etc. It is required, and it should be just immersed into the, you can say, chemical itself. So cost is low. Okay, it is burn free, and tooling itself is not that much available. So its tooling cost is kind of less or nil. But some of the limitations are also there. It's like you cannot go for any kind of depth. Okay, like you have to, there is a limitation in terms of depth of cut. Otherwise, what will happen? Overcut will be there. Okay, undercut will be there. Okay, so limited depth of cut is there, and it is expected that the whatever is the workpiece material, it should be homogeneous structure. Okay, so otherwise chemical will not properly be absorbed from all the sides. Okay, similarly, very sharp radius is very difficult to achieve, and skilled operators will be required for PCM and all. Later on in the next class, we'll be discussing about photochemical machining, which is another variant of the chemical machining itself. Okay, and as we are talking of using these hazardous chemicals, so we have to be kind of health hazard is involved, and even the chemical vapor, etc. These are also inhaling this chemical vapor that is not that much good for health. Okay, so these are kind of some health hazard also is involved. And as you know, we are talking of chemicals. So after a certain time, the chemical will not be fresh. Okay, and it will not have that much. It will be, that is on the chemical itself. Okay, on the inside itself, there will be contamination. Okay, so like the whatever is the metal that is being removed, where it is, actually it is within that particular region itself. Okay, so later on, if we are thinking of going for another kind of another batch of production, we should go for a fresh kitchen. Okay, a fresh supply of kitchen. So in that case, what to be done with respect to the previous kitchen? So it has to be disposed, right? We cannot just keep it because it is of no use. We have to dispose it, but it is chemical. It is not like normal water. Okay, so disposing of chemical is kind of costly. We have to undergo different like protocols. Okay, otherwise you cannot just like dispose the chemicals, used chemicals like that. Okay, so disposing chemical is somewhat costly. So these are some of the limits. Okay, so I'll stop here for today. In the next class, we'll be discussing photochemical machining in detail. Okay, which is another variant of discussing your chemical machining. Okay, so let me know whether you have understood or not. In the meantime, I'll be taking your attendance.
Understood, sir.
Okay, thank you. So respond to your name first. Samim, absent. Hitesh sir is present. Vishwajit, absent. Catherine, absent. Tapas, present. Subham,
Friend, sir.
Andreas,
Yes, sir.
Ashish,
Yes, sir.
Khandip,
Present, sir.
Vishal,
Yes, sir.
Semphang, absent. Jodian, absent. Centering down, centering down. Yes, rejoin, I think.
Sir, yes,
Mario,
sir. Present, sir. Answering.
okay, Mario, absent. And Zaidip, Zaidip seems absent. Okay, so with this, we'll stop here for today. Thank you everyone for joining.
Sir,
Thank you,
sir,
sir.
present.
Where is Zaidi? Okay, Zaidi. Okay. Okay. So thank you everyone. We'll end here.